Okay, now we're going to start solving trig equations. And this notation right here means there's a constraint. It's a restricted domain. Graphically, I'm going to show you what that means. Sine, cosine, all of the trig functions are infinite. They go on infinitely in both directions, kind of like polynomials. They continue. But for this equation, we're just saying between 0 and 2 pi, where is cosine theta at a height of -1/2? So here's -1/2 right here, or right there and right there. Okay, so that's what your job is to find where theta is. But look at, there's going to be two locations. So which two locations? What are the two numerical values? I'm trying to think about this. No, what are the two? So we're looking for where that would exist. Well, remember, on a trig graph, the x-axis is the theta axis. So which thetas will they be when the height is -1/2? That would be a better way to describe what I just said. All right, so this is how we do that. Remember, we're looking for an angle, so some point we're going to use the second function on your calculator. Well, since there's nothing else to do on the right side, we just have to get rid of cosine. Right there, we can take the inverse cosine of cosine, and look what happens. Now, you cannot over here do this. No, you cannot do that. It has to be written exactly like I did it. This does not mean the same thing. This says, hey, I'm taking the inverse of this. Well, they cancel each other out. That leaves the theta. But if you take the inverse cosine on the right side, you've got to take, sorry about that, I'm using two different software programs. You have to take the inverse cosine, and that's of -1/2. Well, you're going to type second cosine -1/2, enter. Now, or you can look at the unit circle and look at cosine is negative in the second quadrant and in the third quadrant. Look at the x's are positive in the first and fourth, so third quadrant. Remember what I said, these are important things to know. Well, right up there and right down there, cosine is -1/2. And up here, cosine is -1/2. Sine would be positive √3. What angle is that? And we want it to be in radians. Well, right there, that's 2 pi thirds, and that's 4 pi thirds. When you type this into your calculator, it's only going to give you one of them. I think it's going, here, let me type it in. And you want your calculator to be in degree mode, and then you'll have to decide what it is in radians. So second cosine -1^5 or (1^2) or -0.5, close parentheses, enter, and you get 120 degrees. Well, 120 degrees is the same as 2 pi thirds. It does not give you the other angle. So using the unit circle is important, because also down here at 240 degrees, which is 4 pi thirds, and we want it in that mode. So theta is equal to 4 pi thirds and 2 pi thirds. Okay, now we still have a restricted domain. We're still going to want our thetas to be in radians, but we have 5 plus cosine theta is equal to 10 plus √3 all over 2. All I did was rewrite this, and I separated out the fraction. So I wrote 10 over 2 plus √3 over 2. Well, look at 10 over 2 is 5. When you have 5 is equal to 5, they cancel each other out, because if we subtract 5 over here, we would subtract 5 over there, and they zero each other out. Now what you have is cosine theta is equal to root 3 over 2. Remember, we want to get the theta by itself, so to the left of cosine, those of you who like to do your own thing, you're going to lose points on a test. So inverse cosine in front, and we're going to write inverse cosine here. Well, when we write inverse cosine over here, what I want you to do is I want you to look at the unit circle. Root 3 over 2 is positive, and remember, cosine is positive in the first quadrant and in the fourth quadrant, because cosine are the x values. The x's are positive. Well, right here, cosine is positive root 3 over 2. Sine is 1/2. And down here, cosine is positive root 3 over 2. Sine is negative 1/2. Well, what values are those? Well, this is 30 degrees, or pi 6. 330 degrees, 11 pi 6. So when you hit second cosine, when you type second cosine, root 3 over 2, you're only going to get the 30 degree or the pi 6. You have to make sure that you include that second theta. So using the unit circle on these is pretty important. Okay, be careful about this one. This is 2 by itself, like an add 2. This is multiplying 2. They do not cancel each other out. So where do we start? Well, the first thing we start is we have to get rid of everything on the outside before we can get cosine theta by itself. So, or before we can even get the theta by itself, because that's on the inside. So first thing we're going to do, since 2 is being multiplied, we're going to divide both sides by 2. 2 divided 2 is 1. So now we have 1 is equal, so let's do this. One is equal to cosine theta plus 5 pi 6. Well, before I can get to the theta, I have to cancel out this cosine. So I take inverse cosine of both sides. So now we have theta plus 5 pi 6. Well, second cosine of 1, you're going to come down here, and that is 0 degrees. Notice it includes 0. It does not include 2 pi. There's not a less than or equal, so you do not go all the way around and include 2 pi. Theta is equal to 0. Well, theta plus 5 pi 6. And now we want to get the theta all by itself, so we're going to subtract 5 pi 6 on both sides. 0 subtract 5 pi 6 is negative 5 pi 6. You're not done, because look at the constraint right here. The domain constraint says our thetas have to exist between 0 and 2 pi. Well, that means we have to find a coterminal angle. To find a coterminal angle that's positive between 0 and 2 pi, we're going to add 2 pi. Well, if 6 is in the denominator, 2 pi is the same as 12 pi 6. So 12 pi 6 plus negative 5 pi 6 is 7 pi 6. There you go. Just like that. Okay, look sharp, because now we have 2 operations on the outside, not just the one. On the right side, we have this positive 2, subtract this 4 being multiplied against cosine. But look at, we have a positive 2 on this side, we have a positive 2 on this side. They cancel each out, leaving a 0 on this side. And now we have negative 4 cosine of all of the stuff on the inside. That's a theta right there. Well, this is a multiplying negative 4, so we're going to divide both sides by negative 4. Well, that's still going to remain 0. Okay, so, sorry, I said stop the video. Well, now before we can get on the inside of the parentheses, we have to cancel out this cosine. So you have to do the inverse operation. Inverse cosine. Right, well, remember the unit circle and remember so this is 1, 0. We're looking at the cosines. At pi halves, the x, or the cosine value is 0. Oh, down here at 3 pi halves, the x value is 0. So when we do this, when you see this notation, you can put in second cosine 0. It's only going to give you the 90 degrees, which is pi halves. You have to look at the unit circle to make sure you find the other one. So right here we can say pi halves, comma, 3 pi halves, the inverse cosine cancel, and now we can say equals theta plus 5 pi fourths. Well, we want to get the theta by itself, so we're going to subtract 5 pi fourths from both of those angles. And if they end up negative, we're going to have to find coterminal angles. Well, since this is pi halves, and we're subtracting 5 pi fourths, we could just write that as 8 pi, let's see, we want 2 pi fourths. So 2 pi fourths, that's the same as pi halves, subtract 5 pi fourths, ooh, that's negative 3 pi fourths. So negative 1, negative 2, oh, negative 3 pi fourths is there. Well, that's the same thing as 5 pi fourths. And look at, if we add 2 pi, or 8 pi fourths, negative 3 plus 8, so 5 pi fourths is one of our answers. And now we have to do the other one. 3 pi halves, well, pi halves, if we multiply top and bottom by 2, becomes 6 pi fourths. Subtract 5 pi fourths. Nice, 6 subtract 5 is just 1. So our thetas are 5 fourths and 5 pi fourths. Okay, I did a couple things here first. On the right side, these are both over 4. I just wrote this as two separate fractions, negative 4 over 4, which simplifies to negative 1. Well, there's a negative 1, so those cancel each other out. So now on the right side, I have root 3 over 4. On the left side, I have negative 1/2. Oh, I need to move that over, not leave enough room. Negative 1/2 times cosine of the stuff in the parentheses. Well, I need to cancel this multiplying negative 1/2, and usually the inverse of multiplying is dividing, but when it's a fraction, we multiply by the reciprocal. So we multiply both sides. The reciprocal of negative 1/2 is negative 2. Well, now look at what happens. The negative times positive is negative, and then the 2 and the 4, they both have a 2 in common. That cancels to 1, that cancels to 2. So now we have negative root 3 over 2 is cosine. This stuff canceled. Negative 4 theta. Now this one's going to warp your brain a little bit, because this negative 4 attached to theta means it's going to be 4 times as wavy. This is what I mean by that. If normally between 0 and 2 pi, the cosine graph looks like this, it's now going to, I didn't do that very well, look like that. It's going to be 4 times as wavy. So you're going to have 4 times the answers. 4 times 2, you should have 8 answers when you're done, because of all of these curves down here. All right, so now what we have to do is we have to cancel this cosine because we have to get to everything on the inside. So we're going to take inverse cosine, which cancels. So now we have to take the inverse cosine here. Remember, when you type that into your calculator exactly like that, it's going to give you one angle. And remember, cosine is negative. Oh, excuse me, cosine is negative, not positive. Negative in the second and third quadrants, and it's negative root 3 over 2 right there at 5 pi 6 and right there at 7 pi 6. Look at your unit circle. That says negative root 3 over 2, and that says negative root 3 over 2. So on this side over here, when we take the inverse cosine, I think what you would get is this 150 right here, or they might even give you a negative value, but I think it gives you 150, but you also have to look down here at the 210. So we're still in radians, so we're going to say 5 pi 6, and we're going to leave some space and put 7 pi 6, because we have some stuff to do over here. And now we're going to write negative 4 theta plus pi thirds. All right, now before we can get to this, we have to subtract pi thirds. Let me do that in a different color. Do that in black. We're going to subtract pi thirds to each of those. Well, pi thirds is the same as 2 pi 6. So 5 pi subtract 2 pi that's going to be 3 pi 6. Well, 3 pi 6, that's the same as pi halves. So we're going to put pi halves there. 7 subtract 2 is 5, so that will just be 5 pi 6. So we have our 2 thetas still. 4 times is wavy and actually in the negative direction. So now we have to find a negative coterminal for each of these. So since this is in the pi halves, we're going to subtract 4 pi halves. Now I'm going to subtract 12 pi 6 there. That's going to give me the first one. So pi halves subtract 4 pi halves is negative 3 pi halves. Another way to do it, if this is pi halves, just count by, go negative. Go negative pi halves, negative 2, negative 3. So negative 3 pi halves. And then 5 subtract 12 is negative 7 pi 6. All right, those are your starting angles right there. So we have negative 4 theta. I am going to pause this because I'm going to erase a bunch of stuff and move that stuff up. Okay, so there's our starting angles, negative 3 pi halves and negative 7 pi 6. But for it to be 4 times as wavy, we have to add another, for this one, another negative 4 pi halves. And for this one, another negative 12 pi halves. Well, that's just a calculator. Negative 3 subtract 4, we have negative 7 pi halves. And negative 7 subtract 12 is negative. All right, that's twice as wavy. This is normal, 2 answers. That's twice. So we're going to add another negative 4. So negative 7 plus negative 4. This is negative 7 pi halves. Subtract 4 pi halves is negative 11 pi halves. And then one more would be negative 15 pi halves. All right. And then to this one, we're going to add negative 12 pi halves, which would be negative 31 pi halves. And then negative 12 again would be negative 43 pi halves. All right, we have gotten that far. So now, the very last thing is we have to get the theta by itself. So we're going to multiply all of these by negative 1/4. We're going to multiply all of these by negative 1/4. And that means our thetas are going to be, well, as soon as we multiply all of the pi halves by negative 1/4, first of all, negative times negative is positive, and 2 times 4 is 8. So this becomes 3 pi eighths, 7 pi eighths, 11 pi eighths, and 15 pi eighths. All right? And when we multiply all of these by negative 1/4, negative times negative is positive. 6 times 4 is 24. So now we're going to have 7 pi 24ths. All the numerators stay the same. 19 pi 24ths. 31 pi. That should have, I don't know what happened there. Those should have been 6s. 31 pi 24ths. So I apologize for that. And 43 pi 24ths. Then you have to look at all of these and see if any of them can be simplified. 3 over 8 cannot, 7 over 8, 11 over 8, 15 over 8. So those are good. 7 over 24 can't be simplified, 19 over 24, 31 over 24, 43. So these are the 8 places down there where, what did it have to, let's see. Oh, I erased it. It was, this is at a height of negative 3 pi, negative root 3 over 2. At that height, it's all of these angles. So 3 pi eighths, and 7 pi 24ths, because these aren't necessarily in order, but those are the 8 places where the height of the graph is negative root 3 over 2.